Hi, geometry. Let's take a look at solving linear systems. So we're only going to focus on 2x2 systems, two variables, two equations, nothing fancy. In Algebra 1, you should have learned how to solve by graphing, how to solve by substitution, and how to solve by elimination. This video is only going to focus on substitution. If you need help on graphing, find my video on graphing lines. If you need help on elimination, I have a separate video for that one. So again, we are only going to take a look at solving a system by substitution. Okay, so let's jump right into this. I am going to solve this system by substitution. What does that mean? That means I'm going to take one equation and substitute it in to the other equation. Now, I'm lucky here because I already have this equation set up with y by itself, which means I can take the right side of this equation and I can go ahead and substitute in for the purple y in the equation above it. Now, if yours doesn't look like this, if it doesn't have x by itself or y by itself, then you have to take that first step of getting x or y by itself. I'll put that in the next example. So for right now, let's just see the main idea behind substitution. Okay, so look what I've done. Exactly what I talked about. I took the right side of the second equation and I substituted it into the y in the first equation. So I tried to keep the color the same here so you could follow. This is the first equation. 2x plus y equals 18. I took the y out and I substituted in that 3x minus 2. This is the idea behind substitution. Why do we want this? Because now I can collect like terms and solve this like I would any other equation. Okay, so I've collected like terms. 2x plus 3x is where I got this 5x. I just brought down the minus 2, the equal sign, the 18. So now we've got this. Add 2 to both sides. I get 5x equals 20. Divide both sides by 5, and I've got x is equal to 4. Easy enough. So I'm done, right? Hey, wait a minute. This didn't just say solve an equation, it was solving a system. A system means that just the x value, that's not enough. You got to solve for x and for y. So I'm going to take this x equals 4 and I can plug it in literally into either equation I want. But you're going to see that the bottom equation actually is way easier. Look at that. I've done another substitution. I have substituted this x equals 4 into this x right here. That's where I got 3 times 4 minus 2. This is where the x used to be. So another substitution, multiplying it out, I've got 12. 12 minus 2, I've got a y value of 10. Now remember, this is a system, and you really should write your answer as an ordered pair. So final answer I'm coming up with is 4, 10. And we're done. Okay, so this time I picked a way harder example, and what makes this harder is that when I look at the two equations, neither of them have x by itself or the term with x by itself, and they don't have the term with y by itself. So you're going to have to do that first step I was talking about previously, where you're going to have to pick an equation and get x or y by itself. Now, looking at this, I don't think it's pretty. I think my best option is to try to get the second equation. I'm going to try to get x by itself. So I'm going to take the blue equation on the bottom and I'm going to solve for x. Okay, so I tried to keep this all color-coded in blue for you so you could follow. This was the bottom equation and I'm solving and trying to get this x by itself. So add the 3y over, divide by 2, and I come up with this. Not ideal because of the fractions, but it's not crazy bad, so it's workable. Okay, so now we just follow the same thing we did on the last slide. We're going to take this equation, we're going to take the right side of it, and we're going to plug it in or substitute it in to the other equation. So this is the blue one. I'm going to take the right side and plug it in for the x in the purple equation. Okay, so when you're doing the substitution, it's really important that you do not solve equation 2 and then plug equation 2 back into equation 2. So I solved equation 2. For me, that was the blue equation. Okay, I got x by itself in the blue equation, so it's super important that I took the blue equation and plugged it back into the purple equation. Now I solved for x, so I had to make sure I put that into the x spot. Okay, so substitution. And I come up with this equation. 3 times 3 halves y plus 15, so it's 3 times that quantity, plus 2y equals -7. Now I'm ready to solve that. Okay, so just to make sure you can follow my work, first things first, I distributed the 3. Distributing the 3, I did have some fractions here, but I'll clear them in a second. I got 9/2 y plus 45. Remember, you got to distribute the 3 to the 15 as well. Then there's the 2y and there's the -7. Okay, these, I wasn't ready to tackle that yet, so I moved the 45 over. So then I had 9/2 y plus 2y equals -52, and I thought it'd be really easy to combine like terms if this fraction wasn't there. So I distributed 2 all the way across to eliminate that fraction. So multiplying by 2 and dividing by 2, those cancel, but then don't forget to distribute the 2 everywhere else. Okay, do you have to eliminate the fractions? No. If you don't mind, maybe you put this as 4.5. Maybe you're okay with decimals. I was just trying to do this without a calculator. So collecting like terms, I've got 13y. Divide both sides by 13, and I've got y equals -8. But just like the last example, don't forget, you have to take this y equals -8 and plug it back into one of the original equations to solve for x. Now, it does not matter which equation you use, but I would go back to one of the original ones. For me personally, I'll probably just use equation number 1. It really doesn't matter. Okay, so taking the -8, I plugged it back in. I went to the top equation. I plugged it in for the y right here in this equation. So 3x plus 2y, or 3x plus 2 times -8, there's that second substitution, is equal to -7. Okay, 2 times -8 is where I got the -16. Add it over. I've got 3x is equal to 9. Divide both sides by 3, and that's where I came up with x equals 3, and leads me to the ordered pair of 3, -8. Now remember, you can always take your answer and plug it back in and check it. If it makes both equations true, then you know, yes, ding, 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 you've got the right answer. Okay? Now, for me personally, I would not have chosen to solve this by substitution. I think this is a long and tedious process, and I would have used elimination here. So if you want to see your second option on elimination, watch that video next. At least